welcome. Let's try to solve another Leetcode problem. 1740, find the distance in binary tree. So we are given the root of a binary tree and two integers. So we should know that the p and q are integers, not node. We're going to return the distance between the nodes of the value p and q. So in this example, p equal to 5 and q equal to 0. So the distance is going to be 3. As you can see, that's going to be 1, 2, and 3. So the distance between two nodes is the number of edges on the path from one to the other. So normally this problem is going to be an easy problem. I think first of all we can think about the graph. First of all, we're going to turn this kind of a tree to a graph because we are given the root. We just need to run a level order traversal or BFS, and then we're going to turn all the nodes into an adjacency list. We don't need to use the reference, we just need to use the numbers because all the numbers are unique. So for example, 3 is connected to 1. So because 3 is connected to 1, we're gonna, for this node 3, we're gonna prepare its children inside an adjacency list. It's gonna be 1 and 5. Yeah. And also for others, let me give you another example. Maybe we're gonna prepare this 5. Yeah. So 5 inside of the adjacency list, it's gonna be like 3, 6, and 2. Yeah. As you can see, it takes time for such adjacency list. Basically, we need to go through each of the node and then build an adjacency list. After that, we just need to run the BFS. So we're going to run two BFS. The first BFS is to build the adjacency list. Another BFS to check the shortest distance. Because while running the BFS, we're going to start from this node 5 and we're going to find this node 0 and we're going to have a distance of 3. I think this is the straightforward way of solving the problem. But this time, I'm going to use another way to solve it. And this way, normally it's difficult to think about it. If you can think about it this way, definitely this is a good point to discuss. So we are having two nodes. This is 5 and 0. Definitely it is inside of the tree. We can calculate the lowest common ancestor. So for example, we can just check the lowest common ancestor of this node 5 and 0. It's going to be 3. Now what are we going to do? We just need to run a BFS to check the distance. 5 to 3, it is 1. 3 to 0, it is 2. So 1 plus 2 is going to be 3. So for this kind of a method, first of all, we're going to run a DFS. After the DFS, we're going to run a BFS. Yeah. But we don't need to go through the whole tree. We just need to check the two nodes. So for example, from 3, we just need to go through to 5 and 0. We're going to get the final result. Maybe this is a good method. Because for building the graph, we have to traverse all the nodes. But for this kind of method, if this node 5 and this is 0 is not just below the tree inside the at this areas, it is not too deep. Maybe it is just shallow. Yeah, in this way, it may save time. So let's just use this kind of method to solve the problem. First of all, we're gonna calculate the lowest common ancestor, which is gonna be this node 3. And secondly, we're going to run BFS to calculate the shortest distance from 5 to 0. Definitely, for the BFS, it's going to be starting from node 3. While we find 5, we're going to record the distance. While we find 0, we're going to record another distance. And we're going to accumulate them together and get the final result. Now let's just use the lowest common ancestor method to solve the problem. So I'm going to put a node inside. So if node is inside PQ, but currently PQ are just values, so we're going to use the node.value. If node.value inside this PQ, so we're going to return the node. So, but as we are calculating the node.value, so this means we have to check first. If not node, we can return a none directly. Now we're going to prepare the left and the right. It's going to be the DFS node.left and DFS node.right. Now we are going to check if left and right, so we're gonna return the node. Otherwise, so we're gonna return left or right. So this is a common method of how to calculate the lowest common ancestors of two nodes. I'm not sure if you are familiar with it, but basically this is just a DFS. So for the left and the right side, this is like a post-order traversal. So if from the left side I can find a node, if from the right side I can find a node. So for example, for this node 3, yeah, let me just explain the code. So currently we are going just from this node 3. From the left side, definitely we can find a node 5, and this node 5 is inside P and Q, inside the array P and Q. Definitely, this gonna be, we're gonna return this node, and yeah, and this node gonna be yeah, this node gonna be 5, another node gonna be 1. But no matter if it is 5 or 1, definitely it is true. So if left and right are true, so I'm gonna return the root node, and this node gonna be the root node. It's gonna be this node 3. So this is the idea. Otherwise, maybe it will go to the left side or go to the right side, but finally we can always find this lowest common ancestor. Yeah. Now, if we can calculate the lowest common ancestor, we're gonna start the BFS part. So I'm gonna prepare a queue. So inside a queue, I'm gonna prepare the root node because I'm gonna start from the root node. But I will prepare a root node at a depth. The depth is gonna be 0 from the beginning because I want to accumulate the distance from 5 to 3 and 0 to 3. Yeah. So first of all, let's just calculate the lowest common ancestor. So I'm going to define it as a root. Yeah, because I'm going to, for this BFS, I'm going to start from the lowest common ancestor. Maybe it is not 3, maybe it is other node. So I'm going to update the root. So the root is going to be DFS with the root node. Yeah. So after that, I'm going to put the root inside and run the BFS. So while q, so node gonna equal to q dot pop left. So if node dot left, I need to put it inside. So if node dot right, so I need to put it inside as well. Yes, let me just put it inside for the right side. Finally, I'm gonna return a result. So for this result, I'm gonna set it from 0 from the beginning. Now I want to check this node. So if node dot value inside P and Q, yeah, it can be P or it can be Q. I don't want to write a node dot value equal to P or equal to Q. I think this is easy to write. So the result gonna plus equal to node dot value. So in this way, my result accumulated 2 values. So from here, yeah, but inside I forget to update the depth. Let me update the depth. So from the left side, I need to update the depth plus 1, and similarly for the right side. So it's going to be the depth plus 1. Now let me just run it to check. There is something wrong. It is a tuple. Object has no attribute val. Yeah, because it should be a node and depth, right? Now let me just run it to check. Something wrong. Yeah, so the result gonna be 3, but my output is 5. It means something wrong. First of all, let's just check what is the root. Let me just print out the root dot value. So for the first example, the root is gonna be 3. Yeah, let's just check that. It seems the output is okay. I output a 3. It means the root node, the DFS part is okay. Only the problem is the BFS part. So first of all, we're gonna pop out the node and the depth, and then we're gonna check if node dot left, and we're gonna append the left side. If node dot right, we're gonna append the right side. So the depth is gonna update it to depth plus 1. So for here, if node dot value inside P or inside Q, I need 2 plus the depth. So instead of a node dot value, because I only prepare the depth for calculating the distance, so that is why it is wrong. Let me just run it. Now it seems the value is different. My output is 1 instead of 3. It means something wrong with it. Yeah, let me just check from here maybe. Let me just print out the depth maybe, and the node.value, because I want to check if I can find those two values. Yeah, I can find a value node 5, but I cannot find this 0. This is a string. Yeah, as you can see, this is why I always make such kind of stupid mistakes. Because here q is a value, here I prepared another variable, it is the q. I have to use a unique variable, otherwise it will make mistakes. So I use QU, EUE. I'm gonna use this kind of Q variable. Yeah, so we have to be careful, otherwise it's really difficult to debug. So let me just update with Q. Yeah, I often made such kind of mistakes. Yeah, so I have to be really careful with the variable names, because this is a Q and this Q is just a variable they are giving a Q. So sometimes if I'm familiar with this Q to represent the real Q, I will definitely make a lot of mistakes. Now let me check if my variable definition is okay. So this is a Q, and inside this Q, with one letter, it's gonna always be an integer. Now let me just run it. Now as you can see, it works, and let me submit it to prove it can pass all testing cases. As you can see, it passed all testing cases, and it's pretty fast. So I prefer this kind of a method. First of all, we're going to calculate the lowest common ancestor, and then we're going to just run the DFS to find the distance. Thank you for watching. See you next time.